Hi, so let's take a quick look at some isotope problems and let's see how we can solve them. All right, so the first question says chlorine contains only two isotopes with mass number Cl35 and Cl37 respectively. If the isotope exists in ratio 3 to ratio 1, what is the relative atomic mass of chlorine? All right, so for this question, it says that chlorine contains two isotopes, Cl35 and 37. It could be written as 35 and 37. Okay, so sometimes the Cl might not be included. Doesn't matter. It's still talking about the same thing. Okay, so in this case, we are going to use a simple formula which I naturally use to solve this. And for you to remember, I'm going to say the formula is isotope. Sorry. I'm going to say the formula is the isotope 1 multiplied by uh, the occurrence of the isotope 1, then added to isotope 2, and then the occurrence 2. Now, this would now be all over the occurrence 1 plus the occurrence 2. Now, what sort of a formula is this? We're going to use it now and you'll understand what this means. Okay, now the first isotope is simply referring to the first one that comes out here. That's Cl35. The occurrence refers to the ratio at which it exists, 3, and then the occurrence 2 is the Cl37 here, and then the isotope 2 is Cl37, right? And then the occurrence 2 is the ratio at which it exists. And when they say something is respective, it means the Cl35 here, 35 here, exists in ratio 3, while the Cl37 exists in ratio 1. It is respective according to how it is lined in the image. Oh, so I hope you've gotten the formula because I'm going to wipe it off now. So we would also better still. I could just do it and we'll work with what we have. Alright, so let me do it this way and let's work with this. Alright, so in solving this question, the first one says Cl35. So I have my isotope here to be 35, alright, then multiplied by occurrence 1, which is 3, plus my other isotope is 37 multiplied by its occurrence in ratio 1. This will be all over the occurrence 1 and 2, which is over 3 plus 1. That gives me, sorry, um, that's an error here. So that's over 3 plus 1, it gives me 4. Now, from here, it's simple and straightforward. 35 multiplied by 3 is going to give me 105. Okay, then this is plus 37 multiplied by 1 remains 37 over 4. Now, coming straight down, I'm going to have 142 if I add this two together to give me over 4. Right, then my final answer is going to be 35.5. I hope you can see this writing properly. Grams, don't forget this is talking about the mass. So it has to be in grams. This is easy and straightforward. Now, there are times that you could be given this in percentage rather than in ratio. Okay, so there are times that you could be told that they exist in a particular percentage. For example, if I say that this ratio is about 75% to 25%, it's easy and straightforward. Remember that the total percentage is all equal to 100. Okay, so if I'm going to be using that in this formula, it's still easy and straightforward. I'm going to say that my isotope 1, which is 35, multiplied by my first percentage, which is still the occurrence because it's occurring at 75%, and that's 75 here, okay, plus my isotope 2, which is 37 multiplied by its occurrence 25%. Okay, this is all over. Now, occurrence 1 and occurrence 2. In fact, you don't need to memorize that. You should just know that the total percentage is all equal to 100. So in this case, I am going to be having 35 multiplied by 75 is going to give me 2,625. So I have 2,625 here plus 37 multiplied by 25 will give me 925. And this is all over 100. If I had this all up together, I'm going to have 3,550 divided by 100, and my final answer is going to be 35.5 grams. So it doesn't matter what it comes out in percentage or in ratio, you'd still get the same answer. All right, so that's it for the first question. Let's take a look at another example. All right, so in this example, we are going to be looking at 3 isotopes now instead of 2. Now, I gave you a formula to say that the isotope 1 multiplied by the occurrence 1 plus the isotope 2 multiplied by the occurrence 2 over the occurrence 1 plus the occurrence 2, right? Now, it turns out that I have 3 isotopes in this question, so I'm just going to add the third isotope. It's easy, isotope 3 and the occurrence 3, and this will now be over occurrence 3, the addition of the 3 of the isotopes. And remember, this is not existing in ratio, it is actually existing in percentage, like I explained earlier. Now let's use this formula to solve this question. You find that this isotope is quite easy and straightforward. Well, for now. All right, so let's go. My first isotope is magnesium, 24 right here. So I have 24 multiplied by my first percentage, 78.6. 78.6. Okay, so I'm going to erase the formula anyway. I hope you got it. Okay. Okay, sorry about that. All right, that's plus. My second isotope is 25. So I have 25 multiplied by the second percentage is 10.1. 10.1. And the third isotope is Mg26, that's 26 multiplied by 11.3, being the third percentage, and this is over 100. If you add this 78.6 and 10.1 and 11.3 all together, they are all going to give you 100. Okay, so let's solve from here and get the proper answer. So 24 plus that multiplied by 78.6 is going to give me 1886.4. Okay, and that's plus 25 multiplied by 10.1 is going to give me 252.5 plus 26 multiplied by 11.3 is going to give me 293.8, and this is all over 100. This is a point here. Okay, so the addition of all of this at the top here will give me 2,432.7 over 100. Sorry, over 100. How do you guys that? If I divide this by 100, I am going to get 24 grams for magnesium, and this is the relative atomic mass for magnesium. So you see it's quite easy and straightforward. There is no problem with isotopy, just follow the formulas. You could give the formula any name you like. I call it isotope 1 and occurrence 1 because, well, That's easy for me to remember. You can use any number, any alphabet, or any figure you like. Just make sure you're consistent with the way you use it, and we're good. So, for the third example, let's quickly take a look at this one, which is a bit different from what we've done. And I'm going to be explaining this so we understand it. It says copper exists. Copper with atomic number 65 has two isotopes, copper 65 and copper 63 and copper 65. I hope you can see this properly. This is 63 right here, and this is 65. I'm going to hold it up my lettering in subsequent videos. All right, it says give the atomic composition. Sorry about this. Now, the atomic composition could be in percentage or in ratio. All right, like we've done earlier. If you look at our previous questions, we multiplied the percentages by the isotope, which is the occurrence, to get our answer, and divided by the total percentage or the ratio. It is literally what we are looking for here, because what it says now is for us to look for either the percentage or the ratio, but in this sense it's talking about the percentage composition. Now I'm going to be showing you how to get the percentage composition and how to also derive the ratio composition from the percentage composition, which is quite easy and straightforward. So without wasting much time, let's delve right in. Okay, so for this question, it's quite easy and straightforward. I'm going to still write out my formula so you get what I'm going to do. It says that isotope 1 then multiplied by occurrence 1 plus isotope 2 multiplied by the occurrence 2 is all over occurrence 1 plus occurrence 2. Now, it so happens that I don't have my occurrence. Now, what am I going to do? It's quite easy and straightforward. I'm still going to fill it in. But before I do anything, I want you guys to understand something. Okay, I'll assume I know what my copper 63 is occurring in. Since I know that my percentage is all equal to 100, I can call my copper 63, so that's my Cu 63 here, to be equal to X. Okay, while my Cu65, 65, sorry about my lettering, is going to be 100 minus X. Remember, this is quite easy. If I have a total of 100% and I have two people to share that 100%, if I can know the percentage for one, I can easily subtract that percentage from the other from 100 to get the other one. It's easy. So for here, I assume I know my copper 63, which is X, okay, and that's an unknown, but I'm just labeling it that. And then my copper 65 is going to be 100 minus the copper 63, which is X. That makes it easy for me to use this formula to solve it. Okay, so here, if I'm going to be creating my formulas, this is what I'm going to do. So please pay attention closely. My occurrence 1 is 63, so I'll put my 63 right here. Okay, I mean my isotope 1 is 63. My occurrence 1, sorry, I'm gonna refer you to this. My isotope 1 is gonna be X. I mean occurrence 1 will be X. Okay, this is plus. My isotope 2 is 65. And my occurrence 2 is 100 minus X. You see what I'm doing? It's quite easy. And this is all over 100. It is all over 100 because the total percentage is 100. And this is going to be equal to the total mass of copper, which is 65. Now, 65 grams. Now, look, I made a mistake in the question, which I was going to write. The question actually said give the atomic composition if their RAM, which is the relative atomic mass, is 65. Okay, so that's the real question. I'm sorry about that. I don't know how I missed that. Okay, so the question says that copper with atomic number 65, which is written there. Oh, sorry, I have it there. The atomic number is 65. It's actually there. If you look at it, you find it here. Atomic number 65 has two isotopes, 63 and Cu65. Give the atomic composition. Okay, so in this sense, I'm going to tell you that um, when I'm writing out my equation, this is going to be equal to 65 because 65 grams, because that is the total of its mass. Do you understand? So don't forget to write out the mass out to this way. Now, if I'm going to be solving this down, 63 multiplied by x is going to give me 63x. Okay, plus. Sorry, if I'm sorry, having difficulties with this tablet. Okay, it's getting better. Right, so this is plus. Now, if I'm going to be opening this bracket, I'll be multiplying what I have outside the bracket with what I have in it. So I'll start with this. 65 multiplied by 100 will give me 6,500. Okay, minus, because I have the minus sign here, 65 multiplied by x will give me 65x. And this is equal to 65 grams. Okay, and this is also over 100. Now, for me to make this easy, I just need to cross multiply everything. Okay, so I have 63x plus 6,500 minus 65x will be equal to 6,500. You see, it's easy and straightforward, right? All right, so um, receiving, um, there's a mistake with this. Okay. Oh, did I say, okay, this is equal to 65x, right? Now, from this stage, this is going to be over 100, right? No, sorry, I'm getting carried away. Sorry about this. I think this is not going to be there because I just cross multiplied this with it. And when I cross multiply, for you to understand that, it simply means that when I have any sign of equal to here, I have to multiply the denominators by the numerators of the one at the other side of the equal to. If I had an equal to 10 here, this will also multiply the numerator here. Okay, but I don't, so I'm only going to be multiplying it by 1. Now, from this sense, I am going to exchange like terms. Okay, now exchanging like terms is quite easy. And then, sorry, I made another mistake. This is not meant to be 65. This is meant to be 64. 64. I'm so sorry about these errors. It's not meant to be. I made the mistake. I'm so sorry. So let me just make it easy for us again. So this is gonna go off right here. Okay, this is now gonna be 64, not 65. I'm so sorry about this. Okay, this is also gonna be 64. This one here is also gonna be 64. 4 here. Okay, not 65. Okay, so if I multiply this by 100, I am going to get 63x plus 6,500 minus 65x equal to 6,400. Now, the next thing is for me to exchange like terms. Exchanging like terms means I'm going to be moving or categorizing or grouping numbers that are similar to each other. Notice how these two have x's behind them. They are going to come together, while these ones do not have any. They are also going to come together. Alright, so what I'm going to do now is that I'm going to move this one down here. And note that when I move it, the sign in front of it, which is this plus, will change to minus. Okay, so let me just give myself some space, some room to walk. All right, so let's do that. Let me show you what it looks like. I have 63x, okay, minus this 65 coming here, 65x, will be equal to 6,400. Sorry about that. Will be equal to 6,400 minus 6,500. Note that this this is lesser than this, so there's going to be minus here. This is also lesser than this, so this is going to be minus 2x will be equal to minus 100. Now from here, I will divide both sides by minus 2 y, because this is the one carrying the unknown. So my x is going to be equal to this. Minus will cross out each other, and then these two will cross out each other. So my x will be equal to 100 divided by 2, and then my x will be equal to 50%. That is the percentage at which that is the percentage at which CU63 and CU65 occurring 50% here. And if this is 50%, obviously if I subtract this from 100, I'm going to get 50% for the other one. Now let's assume that I am told to look for the ratio composition and not the percentage composition. It's quite simple. What I'm going to be doing is, after I get my percentage composition, I'm going to be dividing this by the smallest of the two. Okay, and since I don't have a smaller one, I'm going to be dividing it by the number I have, which is 50% and 50%. Okay, this percentage will cross out, leaving me with ratios. So if I cross this out and cross this out, I have 1 to ratio. This crosses out 1. So what do they exist in ratio 1 to 1. That's the final answer. If I'm assuming that this was in ratio, let's say 75, and this was 75% to 25%. If I'm going to be dividing with the smallest number, it's going to be 25% and 25%. If they cross out, I'm going to be having 3 to ratio 1. Okay, but since this is not the answer, I just use this as an example. Okay, now this is my final answer. I hope you've learned something in this video. Happy to have taken you. Be going further in our next class to understanding how to find percentage composition in compounds. I think I've done that in my previous videos. We'll be moving forward to other calculations and to other questions in chemistry. Please stay tuned, and you would love this. Thank you very much, and have a lovely day.